Example number 4 says we have a point -6,9. It's a point on the terminal side of angle theta, and it's in standard position. Find the exact value of the six trig functions, goodness, of theta. So drawing this in here, there's our initial side. -6,9, that's somewhere over in this quadrant. Maybe up there. The nice thing is our picture doesn't need to be drawn to scale. So this is the point -6, 9. Now we've got a couple equations we're going to use, and you're going to want to write these down. So the sine of some mystery angle, if we know coordinates, is on the terminal side, if we know those coordinates, your y value over r. We'll talk about what r is. The cosine of theta is your x value over r. Sorry, scrolled too far. And your tangent of theta is equal to y over x. Now, where is this r coming from? R is the distance on that side. So from the origin up to that point. Now, how do we find distance again? We're going to do r equals the square root of x squared plus y squared. So in our case, our x is -6, so we got the square root of -6 squared plus 9 squared, which gives us square root of 36 plus 81, or the square root of 117. Square root of 117 is not a pretty number, so let's see if we can break that up. We can actually break up the square root of 117 into the square root of 9 times the square root of 13. And we happen to know the square root of 9 is 3, so we got 3 times the square root of 13. So that's our r value. Now we're going to start plugging things in. Let me zoom back out a little bit. So we said the sine of our angle theta is equal to y over x. So sine of theta equals our y value of 9 over, sorry, did I say y over x? I meant y over r. Over our r value, which is 3 square roots of 13. Now you notice some of that might already cancel out, so we can cancel out part of the 9 and the 3. So if I divide the 9 and the 3, crossing these out, this becomes 3. So we got 3 over the square root of 13. For now, we're going to be okay with how that's written. Let me zoom in a little bit. Our cosine is equal to our x value, which was -6, over our r value, which was 3 square roots of 13. Just like we did in the previous example, we're going to reduce where we can, so this becomes -2. So we got -2 over square root of 13. I missed a 3 earlier. And then tangent is our y value over our x. So tangent of theta is equal to 9 over -6, which we can reduce down to -3 over 2. Doesn't matter where you put the negatives on these, folks. Just make sure there's only one. You can put it out front, you can put it on top, you can put it on bottom, just as long as there's only one. For cosecant, secant, and cotangent. Cosecant is just the square, or just the reciprocal of sine. So we're going to have the square root of 13 over 3. Secant is the reciprocal of cosine. So we have square root of 13 over -2. And tangent is cotangent is the reciprocal of tangent. So we're going to flip that over and get -2/3. And again, for now, I'm going to be okay with leaving the square roots in our denominator. We'll rationalize those later.